Hello and welcome to my ETF Analyser project for the NEA task of the AQA Computer Science A-Level. I will start by giving a brief overview of my project and then move on to the testing process of this project. I'm currently on the Yahoo Finance website and have set up a simulation portfolio containing 3 ETFs in order to show the problem that my project solves. As you can see here, the holdings for the CNX1 ETF are displayed. In the second row, it's clear that the Apple stock makes up 12.21% of this ETF. However, in another ETF called GSPX, the Apple stock makes up only 7% of this ETF, as shown here. As you can see in this simulation portfolio, there are 3 ETFs. The market value that the user has invested in the first ETF is £5,956.50, the second is £704, and the third £1,012. In this portfolio simulation, the user holds only 3 ETFs. However, in a real-world situation, the user may own hundreds of ETFs within their portfolio. As previously mentioned, each stock has a different weighting depending on which ETF it's in. This is a problem when the user wants to calculate the money they have in one stock over all the ETFs they hold. These 3 ETFs may hold the same stock, but the stock has a different weighting in each of these ETFs, meaning that the money they have in that stock is different per ETF. An issue arises is there could be hundreds of stocks within an ETF, meaning it would be a very long task to work out how much money they had in each stock per ETF over all of the ETFs they own. I have solved this problem by using a SQL Server database which stores the investment data for multiple customers. I have coded my project in C# via Visual Studio. I have used a combination of direct SQL commands and stored procedures in order to query the database. I have also created an extra section in my project where the line of best fit is plotted for 2 ETFs over a certain time period. The correlation between the prices over time of these 2 ETFs is also displayed, and investment advice is also given. I will now briefly go through the project before starting the testing process. When the project is first run, the user will see 2 buttons, one to rebuild the database or one to run the application with the current database. I will start by pressing the Rebuild Database button. I am then asked if I would like to rebuild the database, in which I confirm. I am then asked to enter the database password for the user ID ETF Analyser. The password needed is ETF Analyser 2022 ! And then I press Enter. I am granted access to the application. The application now checks if the tables in the database are created successfully, in which they are, and also that the stored procedures are created successfully. I can now run the rest of the application. I am told to select a customer before I begin. I will select Mr. Stephen Tries. I can now select an action. The first action is to check his portfolios. Here he has 3 portfolios, an ISA, a JISA, and a Bear Trust. The next section is to press ETF Holdings. Here we can see all the ETFs that the customer owns, as well as the quantity held, the unit price paid for each ETF, and the total price paid for each ETF, and this is across all of their portfolios, as shown here. The next section is the stock exposure section. Here we can see all the stocks that the user has indirectly invested in via the ETFs across their portfolios, with the original invested shown and also the current invested shown. This box says to double-click a stock in the left-hand pane to show which invested ETFs contain that stock. I'll double-click the NVDA stock ticker. Here I can see that NVDA is part of CNX1 ETF and GSPX ETF with a weighting of 70% in CNX1 and 35% in GSPX, showing that this is the total amount paid for the NVIDIA stock within the CNX1 ETF, and this here is the total amount paid in the GSPX ETF for the NVDA stock. This list view on the right can also be sorted ascending and descending by all three column headers by pressing at the top of the column header. Here an arrow is shown to show which way the columns can be sorted by. The next action is to look at the margin data for the selected customer. Here all the stocks that they have indirectly invested in are shown, with the original invested, the current invested, and then the margin is shown, which is the difference between the two. And finally a percentage change is shown so the customer can see which stocks have been performing the best over all their ETFs across their portfolios. I also have a reset button which will clear any list view that's on the screen. I also decided to add an extra section past the user's requirements. This is to compare two ETFs. I can compare CNX1 and BATG, or BATG and WQDV. I'll choose the top one. Two graphs are shown in separate windows. The first graph shows the prices over time of the CNX1 ETF, and the second graph shows the prices over time of the BATG ETF. A line of best fit is also shown for each graph. Over here, the CNX1 and BATG ETFs are compared, and the correlation coefficient between the two is shown. An explanation is then given for the meaning of the correlation value, and finally investment advice is given based on the value that is calculated. I can then close these windows and choose the other option to see the comparison between those two ETFs, as shown here, with different correlation and different graphs shown. I will now move on to testing my program. The test plan in the documentation can be referred to in order to see the order in which the tests are carried out within this video. I will start by pressing the Run button. And the main window opens as expected. I will test the Rebuild Database button first. The confirmation box appears with yes and no and the two original buttons hidden as expected. First I will choose the No button, and I am taken back to the original screen. Next I will press the Yes button to rebuild the database. I am then asked to enter the database password for the user ID ETF Analyser. This is the correct user, as in the database connection string source file, the user ID is also ETF Analyser. I will now type in a random string into the password box, which is not the actual password needed, and press enter. I've put in a breakpoint to show that the hashed data, which is the hashed version of what I just typed in, is not equal to the hashed version of the stored password. This hashed string is read from a source text file called hashed password file, which is the same as this here. But the hashed version of the string that I typed in is not equal. We'll continue with the program. Access is denied as the two strings do not match. I am then asked to re-enter my password as the password was incorrect. I will now test what happens when no password is entered. To do this, I will just press the enter button. Once again, I have used a breakpoint to show that the two hashed strings are different. I will continue. And once again, the access is denied as expected. I will now enter the correct database password, which is ETF Analyser 2022 ! And press enter. I've used a breakpoint again to show that the two hash strings match. I will continue with the program. And access is granted as expected. I press OK. I have put 3 breakpoints into my code to show the database being dropped, created, and set up. I will now step into the code. I will open up SQL Server Management Studio, where my databases are shown. Currently, I have one database shown, but now when I refresh, the databases have been dropped, as expected. I will now continue with the code and step into it. Once again, I will open up SQL Server Management Studio and refresh my databases. Now I have a database called ETF Analyser as expected. I will now continue with the code and once again step in. I will again open up SQL Server Management Studio and look at the tables within my ETF Analyzer database. And as expected, there are now 6 tables. I will also check that the stored procedures have been created. And here are the 4 stored procedures. I will now continue with the program. I am told that the tables have been created successfully and that the stored procedures have also been created successfully. I now have a breakpoint in to see if the database has been populated with the data. I will now open up SQL Server Management Studio in order to check if my database tables have been populated. I will do this by selecting the top 1,000 rows, and the data is shown. All the database tables have now been successfully populated. I just want to show that the database tables have actually been populated with the correct data. So I'll pull up SQL Server Management Studio again, and this is the portfolio holdings table. And I'll put on the screen my portfolio holdings source text file, which is where these text files are where all the database tables are populated from. So the portfolio IDs are here, which match up with the first column, the quantity held, the ETF ticker, matches up, the quantity held match up, then the unit price paid GBP also match up with here, and then the total price paid is a calculated column within the database table. I will now continue with the code. We can now continue with the main application. However, I will close the application and rerun it to show what happens when I press the Run Application with the Current Database button. As we already had a database populated from the previous steps, this button works, and we can now continue with the main application. I will now drop the current database and try to run the program by choosing the Continue with Current Database without actually having a database. To do this, I will open up SQL Server Management Studio. And here you can see that I have an ETF Analyzer database. And then I will execute this code to drop the database and refresh my databases. Now I do not have an ETF Analyzer database. I will go back to my code and rerun the project. I will choose the Run Application with Current Database button, and as there is no database, I am told to restart the program and click the Rebuild Database button. I was just told to click the Rebuild Database button, which is what I will now do. I will show this quickly in order to get to the main application window. Now I'm at the main application window. I am told to choose a customer to begin. However, I will now test what happens if I select an action before selecting a customer. I am still told to choose a customer to begin, so now I will choose a customer. I can now try and select an action, and it works, as expected. I have chosen the portfolio's action, and below in the list view is all the data for the selected customer's portfolios with a portfolio ID, name, and description. This is the correct data selected from the database. In the debug window, it says debug updating portfolio dataset for Stetry from database. This is a message I have displayed to the debug window and shows that the dataset has been populated from the database, and then the list view shown here has been populated from the dataset. I will now choose the ETF Holdings action. Another list view is populated with data. However, I want to show that this data is the correct data from the database, so I will use an Excel sheet and replicate the stored procedure. This is the stored procedure which selects the data from the database to show the data for the ETF holdings for the selected customer. Here is the list view that displays the ETF holdings data for the selected customer. Now I'm going to pull up the Excel sheet I've created to show that this stored procedure to get the ETF holdings or portfolio holdings for the customer actually selects the correct data from the database. So we've got the customer table, which is customer table from the database filled in, the portfolio data from the database filled in, the portfolio holdings data, and also the ETF listings data, as these are the tables used in the stored procedure. Now the selected customer in this case is Stephen Tries or Stetry, which is the customer username, and then this is joined with the portfolio table, so I've highlighted all the rows where the customer username is Stetry, and then this is joined to the portfolio holding table where all of the portfolio IDs match. So it's 20, 25, and 30, which are all of these rows here. And then finally, this is joined to the ETF listing table where all the ETFs match. And all the ETFs are within these portfolios. So all of the ETFs and their rows are highlighted. And then where there are green boxes, these are the columns that are selected from the stored procedure in here, with a bit of formatting on some of them for the currencies. So then the query orders the result by portfolio name and ETF ticker ascending here. And this is the result from all the highlighted rows all put together here. And now I'll pull up the window and you can see that the data in the Excel sheet, which I've selected as if it was the stored procedure, matches the data shown in the list view. So the list view displays the correct data from the stored that is selected from the stored procedure. So in summary, the ETF holdings list view displays data for the customer selected about all the ETFs that they hold across their portfolios. I'll now select the stock exposure action, and this shows all the stocks that the selected user has indirectly invested in via their ETFs across all of their portfolios, with the original amount they've invested per stock and the current amount they've invested per stock. And this is the information, the important information that is the main focus of this project, to let the user see how much they have invested in each stock so they can make a decision whether they think they've got too little or too much invested in a singular stock. This data is also selected from the database correctly using another stored procedure. Now this box here says double-click a stock in the left-hand pane to show which invested ETFs contain that stock. So I'll choose the Apple stock and double-click. Now we can see that the Apple stock belongs to the MVUS ETF and the CNX1 ETF with a weighting of 30% for MVUS and a weighting of 10% for CNX1. And we can see how much is that stock makes up that ETF with the amount that the user has invested into the ETFs. And this list view on the right also displays the information via a stored procedure, selecting the data from the database correctly. I'm now going to check that the sorting capability for the list view on the right works. So you can press each column header and it will sort the data by ascending or descending, alternating between when you click the column headers, and this works correctly as expected. I will also just quickly show what happens when you double click on the other stocks, showing that the list view on the right updates. And the sorting capability still works when you change the stock selected. I will now select the margin action. The below list view shows the stock tickers that the selected user has indirectly invested in via their ETFs across their portfolios, with the original invested for that stock, the current invested, and then the margin, which is the difference between the two, and the percentage change, which is calculated. The percentage change is useful for the user as it can let them see how well the stocks have been growing or going down, which can help them make their decision which ETFs they want to invest in, or if they even want to invest in just individual stocks based on the growth rates of the stocks shown here. Once again, the data for this list view is selected from the database via another stored procedure, and all data in this list view is displayed correctly. I will now test that the reset button here works. The purpose of this reset button is to clear the list views on the screen so that the user can reset their data viewing process. So I'll click it and the current list view is cleared, and I'll try it with the other list views and they're also cleared. Two list views and they're both cleared. So this button works as expected. The final action to choose from is the Compare ETFs action, which when clicked displays a drop-down menu of two options. You can compare the CNX1 ETF with BATG ETF or the BATG ETF with the WQDV ETF. This is the additional functionality I've added to my program, which is past the potential users' requirements. I will now click the top option. Two instances of the graph window are displayed, one for each ETF, which are correctly titled at the top of the window, and then a graph is displayed in each window with the axes also correctly labeled with price in pounds and the day along the bottom. The green line graph shows the prices of that ETF over time, and then the red line shows the line of best fit in order to show the growth pattern of that ETF over time, and this is done for both selected ETFs. The axis is also is different for each ETF depending on the price range of the ETF displayed. I would also like to mention how on the graphs the user can click down on one of the lines and see a more in-detailed view of the prices and the day. This shown is for the line of best fit. This can also be done for the ETF prices line, and this can be done on both graphs. as shown. I will now show that the lines of best fit for each graph have been displayed correctly. I'll choose the top option. Now I've put in 2 breakpoints to check the gradient and the y-intercept of the line of best fit, and this will be for the first ETF chosen, which is CNX1. So I'll step into the code, and the gradient is 0.31, and then I'll step into the code again, and the y-intercept is 549.67. So I'll open up an online linear regression calculator. I've already put in the x values, which are just 1 to 20, as they are the days, and then I'll copy my CNX1 prices from the source file and paste them into the y values, and then I will press calculate the regression equation. Now I can continue with my code, and the CNX1 graph is displayed, which is exactly how it should look, as shown by the online linear regression calculator, with the line of best fit being the same for both graphs. The equation of the line of best fit is 0.31x plus 549.67, with this value here being the gradient and this value here being the y-intercept. And these two values match with the two values displayed via the breakpoints in my code, meaning the line of best fit that is displayed in my application has been correctly calculated for the given data points from the source text file. The gradient and the y-intercept of the BATG ETF graph has also been correctly calculated via my code. When the user selects two ETFs to compare, an ETF analysis window appears with the two ETFs chosen, the value of the correlation of the prices of those two ETFs over time, the meaning of this value, and some investment advice based on the calculated correlation coefficient. The user can use this advice in order to change their investment style in the future. I will now show that the correlation value displayed has been calculated correctly by the algorithm in my code. So I'll select the top option, and a breakpoint has been put in, and I will step into the code, and the correlation coefficient is negative 0.958. Now, I'll use an online Pearson correlation coefficient calculator, and I'll copy in my values for the two ETFs selected. And I'll calculate the value. The value calculated by the online calculator is negative 0.9584, which matches the value calculated by my code, negative 0.9584. And this is the value that can be seen down here in the analysis window, where the correlation coefficient between CNX1 and BATG is displayed. The user can now close down these windows and select the other ETF comparison option, in which the correct graphs are displayed for these ETFs and the correlation between these two ETFs is displayed, with different investment advice given as the value of the correlation is different. So in conclusion, my project solved the issue of an investor not knowing how much they had invested in a stock when their portfolio consisted of many ETFs. My program also gave a comparison between ETFs with investment advice for the user so they can change their investment style in the future. This project was also coded in C# and made use of a SQL Server database. Thank you very much for listening.